Up next, our subject is going to be cybersecurity, something that's pervasive across all industries as we are moving from tech-enabled to tech infrastructure. For this, our moderator is Pravesh Dave. Pravesh has been a tech reporter for the LA Times since 2013. Now, he focuses on business issues surrounding local tech companies, the digital media industry, esports, video games, and cybersecurity. Joining Pravesh, we have Nagraj Kashyap. He's a corporate VP and the global head of Microsoft Ventures. Nagraj has over 20 years experience in mobile and software with an emphasis on venture capital. And prior to joining Microsoft, he was senior vice president for Qualcomm Technologies. Also, we have Stuart McClure. He's the founder of Cylance Incorporated and also serves as chief executive officer and president. He is a proven technology industry veteran with more than 25 years of executive security leadership expertise. Please help me welcome them up.
Go on that. Stuart sit here.
Okay, thanks.
Hello. Thanks, Stuart. Thanks, Nagraj. So I figured we'd start by just getting a lay of the land, kind of understanding what are the threats out there right now. What are you seeing that's really top of mind? And I think, Stuart, you were saying that there's really 3 types of threats right now in cybersecurity, right? Can you sort of help me walk through that?
Well, yeah, I mean, there's a lot of different types, but at the core of all of these types of threats really are 3 different ways of getting in to a target system, whether it be a network or database or an endpoint, computer, server, what have you. It's really the first and foremost, which is 99.9% of all attacks, have to include some form of execution. In other words, some kind of code has to run in the target computer or laptop or mobile phone or server or virtual desktop or whatever, but it has to execute in memory and CPU. That's 99.9 of all the threats that are out there. About half of threats use some form of authentication or identity bypass. So in other words, like guessing your password or capturing your password or finding it on a Post-it note on your monitor or on your desk. So that's the second core version of the attack surface area. And then the third is what I call resource starvation or denial of service, distributed denial of service, you name it. Basically sending or using the features of the target in such an overt and exhaustive way to actually bring down a system or a network and just starve it of resources. I always use the analogy of the I Love Lucy episode where she was on the conveyor belt line putting the chocolates in the boxes, and the chocolates started to come too fast, and so she would put them in pockets and put it in her mouth, and it was just too much for her to come on. If Desi had come by at that point and asked a question of her, she wouldn't have been able to answer anything, and that's the same thing that attackers can do to target computer systems and networks. So if you look at the security landscape and the world really of security, cybersecurity, in those 3 buckets, everything else runs on top of it. So you can look at every other solution. SQL injection, web attacks, that's execution. Identity access management, privilege access management, that's all identity. Authentication authorization, that's all identity. DDoS, TCP IP, DNS, DOS, all that's on resource starvation. So they're all very simple to understand in that space.
So we got 3 types, the execution, the authentication, and resource starvation. What are the capabilities at this moment that are sort of most widely used to stop those 3 vectors?
Well, the only thing that's been made available, quite honestly, ever since the industry has really begun, is what we call signature-based technologies. And I define a signature as if a human being can actually describe it to you, then it's a signature.
Describe what?
Right, describe that something is bad, for example. Like, how can you describe that a computer, that MacBook, has been hacked? Well, if a human being can say, okay, well, his MacBook was hacked because first we got a username and password, then we went in and put in a USB stick, which then executed this file, which then opened this portion of memory, injected this process into this memory, et cetera, et cetera. Well, that is a signature, because a human being can actually define it, and it's finite. And that's been the only really available solutions for all three of those areas and those three spheres. Really, honestly, up until the advent of true machine learning and AI. And so now my hope is with this pure, really pure form of learning from the past to predict the future without having any signatures of any sort, is really the hope, I think, for cybersecurity. And I think it's actually possible. So I'm very hopeful about that.
So right now, software written by humans input a signature, and the software waits to see that signature on a computer. Is
Right,
basically
that's exactly it.
all we have to defend attacks at this point.
That's right. And signatures are developed after a patient zero, so after somebody's been hacked. So you could never call any of the solutions that we have today truly preventative. They're protective, and that's a big difference. So I don't know how many of you have home security at your homes, okay? I've got ADT, but there's a lot of them out there, Vivint. You can use some of the newer cool technologies like Arlo and Ring too. But at the end of the day, they are not preventative technologies, right? They're just protective. But I think we as humans think, oh, that's the same, yeah? But I was asked, would you rather know that the burglar's in your daughter's room at night so you can call the cops, or that they can call the cops? Or would you rather prevent the burglar from coming in the house in the room at all? And I don't think up until recently, really, we've been able to even discuss what prevention really means in preventing an attack. We've just been able to protect, and a better term for it is detect it and respond. So detect and respond. And so I think for the first time ever with the advent of true learning systems and learning from the past in such a robust way with such large data, we can now actually predict the future before it starts and runs, executes, and we can prevent the actual attack.
So how does that fit in? What data is being looked at? How is this new software writing itself so that it can stop a attack we've never seen before?
Well, the important part, of course, as always, you probably hear it 100 times, right, is the amount of data. You just need as large amount of data as humanly possible, because it has to be all-inclusive of every possible variation and variant, and inclusive of all techniques, for example, in the malware case or security case. So if you get a large enough data set of all samples or attacks ever created, and you're able to extract enough features from all of those, where it's no longer signature. I can't go back and say, oh, well, this thing does this, and this. I don't even know anymore. It's literally abstracted with mathematics. When you can get that, now you can truly learn so much from the past and be able to predict it in the future in real time before anything actually occurs. And unfortunately, that's what, most people just don't even realize that prevention is truly possible. They sort of just settle for, well, I'll just catch it somewhere along the way and that'll be fine, until they get hit, and then they want to change.
So Microsoft, how are you viewing where AI fits into the cybersecurity landscape? Is it what Stuart's describing, or are you seeing a different way where AI can fit in?
First of all, I think I just want to say Stuart is the actual expert here. They put a VC here before they learned, as everybody knows yesterday, VCs are worthless. So Alan didn't know that before he put me here, so now he knows it. Next time he won't make that mistake. Given that, I don't think there's anything different than what Stuart said. What I'll expand on is, on the attack surface you mentioned, I mean, the thing is that it's such an evolving, the software paradigms are evolving, something that attack surface keeps increasing. Now there's so much new development happening in containers. Guess what? That's going to be big enough in a few years, that's going to be attacked. So every time that we think we've protected something, there's people move to different ways of actually developing code, and then that sort of becomes an attack surface. On the prevention side, we're definitely seeing a number of companies that are trying to do prevention in different ways. I mean, we saw honeypots last year. In a couple of years, they've actually become much more sophisticated to be able to catch attackers, or at least divert them, so before they actually do any damage. So we're seeing things like that happen. Now, just stepping back and say, do those need AI? I think what Stuart described is a really good use case of using AI and machine learning. What I feel frustrated about is, sort of every second startup I see says, I'm AI-powered SaaS solution, born in the cloud, and an IoT platform. So for some reason, if you don't have all those buzzwords, there's a view that you can't get funded. Yeah. And I give this example of the omnivore's dilemma, and you feel that, you read the book and you say, what is organic? And the same thing is what's happening to AI. And everybody says I'm organic, and it could be industrial organic, which is really not organic. They say free-range chickens, which means the chickens have actually in the cage have the option to go out, but don't really go out. Okay, but that's considered free-range chicken. So when I hear somebody saying I'm AI-powered, it really means nothing to me. What I ask them to say is, what is the business problem you're solving with the killer team you've assembled, and which will open up this multi-billion-dollar opportunity for you? And by the way, if AI helps you in that, that's great. But if it doesn't, it's fine. We've actually done 2 cybersecurity investments, and neither of them use AI, which is perfectly fine for them. In the case that Stuart described, where you could do this feature abstraction of massive amount of signatures and then sort of preconceive these models, it makes a lot of sense. So I don't view this as the only silver bullet. I view it as when it's required, it makes sense to use it, and when it doesn't, there's actually very good ways to prevent attacks without having to use AI. So I'm just sort of saying, let's make sure we understand what the business problem is, what attack we're trying to prevent, and if you can use AI, which there is a lot of AI uses. So for example, because of the big data we have, we can see now on the post-processing side, I mean, Stuart talked about the prevention, but just on the logs and
post-processing meaning what?
On the SOC side, for the Security Operations Center, there's actually a shortage of professionals for incident response. You just can't manage all the alerts that are coming up. So there's companies like Hexadite and PatternX, which are not portfolio companies, so I'm not sort of pitching my own companies, that are then saying they're actually seeing how humans react to that, how they analyze it, and then they go and automate that much faster with lots of data. But that is sort of basically taking the fact that there's shortage of professionals in that area and using AI to help with that. When there's a big data, there's a lot of data available. That's a good use case for that. So there's so many different ways you can use AI in security, but it's not a requirement. I don't think it's a requirement. So.
I think it's a great point, though, about using the buzzword terms.
Yeah.
It drives me nuts because, we'll have legacy competitors. I mean, 30-year-old companies who say, oh, no, guys, we've been using AI for a long, long time. And so we're just as good. When they test, they don't test as well. And so you're like, well, why did you say you're using AI? Well, what they've been doing is they've been using machine learning to create more signatures. So they can't use AI to convict in real time. They just create more signatures faster. It's a way to automate their signature process. So when you do hear that term.
But what's the difference between the signatures that they're gathering and the ones that you're stopping because you are also looking at past data?
Yeah, so the difference is that their signatures are very human readable. It's something that they can, they'll explain to you every time. So if you're a big AV company customer and you get hit with something, you get compromised, hacked up, and you send them the sample and they'll write a signature for it and they get it back to you. And you can ask them every single time, okay, why did you miss this? Like, what's in this, and what's in the new signature that now it'll catch this one? And they can describe it for you, like step by step by step. That's very much a signature for me. When you really apply AI in real time to make decisions on whether something's good or bad, there are literally billions and quadrillions of permutations of these features. I can't begin to tell you, human speak, oh yeah, well, this is why we think something is bad. So it's part of the mental challenge that I think a lot of customers have sometimes is they're like, Stu, okay, you said this thing's bad and you stopped it, but why is it bad? We'll say, I don't know. I'm telling you it's mathematically bad. If you don't believe me, you run it, feel free, and they do, and then they get hacked up. So what we try and do is put context around it. We cluster on certain features so we can give some context around, well, what is this? What do we think this thing is trying to do on the system?
And an uncertain feature, meaning it's trying to access a folder on the computer that hasn't been accessed in 5 years. Or
Take ransomware, right? Well, it has some form of encryption where you can encrypt the thing. and it seems to prompt you for something before, you can use it. That's not a passcode, something like that, right? So there are certain buckets of features and API calls and certain characteristics of the PE in the header and things of that nature that make it very, very distinctive of malicious versus safe.
So you were saying that some of the companies that you have looked at, they use it as buzzwords, but there are a few companies that use AI in cybersecurity, I think, right, that you've seen that do it well, perhaps?
Yeah, and I think, as I said, the companies that do it well, to Stuart's points, they're doing something that is different than past approaches, and they're leveraging the use of the enormous amounts of data we have. Not only the data we have, they're able to process it and store it, which was not possible a few years back. You just couldn't do it. And so when you're doing things which I mentioned, whether it's a pattern X or hexadide, which is sort of these next generation SIEMs, you couldn't have done that in the past. And those are not only new machine learning techniques, because machine learning just as a construct has been used in the past in security. It's not like a new construct. But some of the more advanced mechanisms require more and more data to be thrown at it, and that sort of is only a recent phenomenon. So they're doing that. We've seen companies like Vectra, another actually Coastal Ventures company that's doing sort of in-network real-time detection. So these are companies that are doing it because they have access to data and they can process it in the sort of the speed that you couldn't do it a few years back. And that's what is, I think, fundamentally different in machine learning from just a few years back. Forget about security. And that's why I think when I say, when people say I'm using AI, you got to figure out if the domain actually not only requires it, but actually benefits from it. And in this case, this is actually one of the few domains that actually benefits from it, because you have massive amounts of data that you can then process and gain insights out of it. If you don't have that characteristic, just putting AI for some recommendations and things like that is just not useful. But so we have seen companies use it to good effect. I think it's still early days. I think probably Cylance is one of the companies that has made the most progress in terms of commercially in using it and had a lot of success, because the use case really made sense.
That brings me to something I wanted to touch on, which is sort of startups are the breeding ground for these, new products and these new technologies. How does it get out to the masses? If this is the best in class, can everyone afford what Cylance is offering, or will Microsoft, will Amazon, will the big cloud service providers buy up all these companies and sort of standardize these new AI cybersecurity features? How does this go to the masses, or can it go to the masses, or will there be haves and have-nots?
Well, I think from a cybersecurity perspective, it absolutely can. We're doing our best to get it out everywhere as much as possible. We're looking to release a consumer version later this year as well. So right now we cover all corporate, from small all the way to big. 5 people to 5 million is what I always say. But the consumer side of the house is the other half of the business that we've got to release. And then of course IoT and delivering these kind of mathematics into the chip and the running process itself on embedded systems is, I think, also the ultimate potential. And getting into all 3 of those venues, I think it's perfectly fit for all 3. And so it's really just a question of, Jeffrey Moore's model of like, okay, well, when do they come on? Early adopters, late adopters, early majority, late majority, et cetera. And it's a psychological thing more than anything else, I think, especially for consumers, of when they take the leap of trying a new bit of technology. I mean, we've had deals where, we've been doing so well, but we certainly will lose from time to time, and in a competitive situation. And almost in every case that I know of, and I actually get involved and I try and understand, okay, what happened. In fact, I just had to call this one. And he's like, look, Stu, the tech and what you're doing and the promise of this is the future. We know this. But politically, I can't go there yet. Like, my bosses don't get it yet. My bosses don't see the future with pure AI, and they're worried. They'd rather stick for another year with the devil versus this,
Well, and they want to understand why something is bad. Probably,
yeah, right, exactly. And so, it's a psychological thing. It doesn't make them any more secure. I mean, they're much less secure by sticking with what they have. but they don't always readily see it. And it's almost that red pill, blue pill phenomenon, like you're just sort of stuck in it. And that does happen from time to time. So I think the biggest inhibitor is just fear. It's nothing more. It's not technical. Technically, we can do it today.
What's Microsoft going to do with the cybersecurity investments you made? I mean, do they eventually get swallowed into the Azure platform, or what happens?
Well, there's no preconceived notion. They could get swallowed into Amazon. That's perfectly fine. There's nothing saying that we have to swallow it. They can be very good independent companies, just like Silence. But I think just touching on a few points, the black box issue with machine learning and AI is an issue, because effectively, it works, but you don't really know why it works. And as we've seen the next generation of companies that are coming, figured about security on AI itself, trying to demystify that and more democratize that. So as you go from this, just from a data scientist usage of AI to I'm a software developer and I can then program in a higher paradigm without having to worry about learning applied statistics and having to get into this deep ML, as more and more people start to understand how AI actually works and why the results are coming, I think that will actually take away some of the friction in terms of using these kind of techniques. And I think that's definitely coming. It's not the case that only a few PhDs and 20,000 data scientists will be the holders of ML here. So I think that will change how this gets adopted and why people understand that why it's good and why the results are coming up as it is. So that's one aspect that is, I think, happening on a horizontal level. On the cloud side, clearly what we are seeing, whether it's cybersecurity or anything else, there's definitely people who can afford it's not only systems, but also the people to run those. And so you have sophisticated IT staff that can run these systems. And even with the best of them, you still need some IT staff. And there's some companies that won't be able to afford them. Not only just afford them, but cannot hire them. I mean, this is a place where there's negative unemployment. So even if you want, you can't hire them. And those will have to depend on the cloud providers to provide that for them. So it's not like they don't want to do it themselves, but they may be forced to use somebody else. And I think Microsoft and Amazon and other cloud providers will do a good job of providing access to folks who can't get it themselves. And at scale, it might be cheaper for them to do it. But there's some that are completely worried, want to have it more control. They have the power to hire IT folks, and they will do it themselves. So I think this is a world that always has existed, not just for cybersecurity, for other things. So I think it'll continue like that.
So there's been a lot of talk in this space about collaboration and like threat sharing. Facebook, Google, the large Silicon Valley companies, they say they work together to share cybersecurity threats. In this new space with AI, where there's a lot of research happening at universities about how machine learning works, a lot of research within companies about how this works, is there collaboration in trying to develop the most sophisticated, defense that is based on artificial intelligence, or are all companies working sort of in their own worlds?
I think there's quite a bit of collaboration, that I've been seeing, but it's really just coming to the forefront with folks like Google now and sharing, Google AI and others, where people can actually develop on it now. That's really where it's, I think, coming to the masses. Certainly in the university sect, everybody's been sharing it for quite some time. On the company, it's tough to share too much from a company because a lot of work goes into perfecting what's available and out there and options. But I think there is always that backdoor kind of collaboration for sure, and talking about, how do you solve this problem and what's the best algorithms for this application. And we talk about security being a pretty good application of AI, but a lot of people go astray, when they try to solve the problem. They have really high false positives, for example. They don't know how to solve that problem. And so when you figure it out, the last thing you want to do is tell the world necessarily. So it's this constant trade-off and balance of, wanting to help the community at large that doesn't have Silence or a technology like it, but at the same time, covet the IP so that you can finally rid the world of, quite frankly, the garbage that's out there. And that's my constant battle.
No,
what do you see?
I think there is a lot of sharing going. By the way, Stuart told me in the speaker room he's going to publish a link to his proprietary algorithm, so I don't know why he's backing off that.
I'll
But-
send you all my source code. Go
As a
for
source
it,
code.
yeah.
No, I think that there is. I mean, we're taking a position that we want to make sure we democratize AI, not just for security, but for everything else. So the collaboration with OpenAI. Also, there's a lot of collaboration between researchers. We publish a lot of papers in this area. We participate in things like ImageNet. But I think this is at the point where everybody wants to fundamentally make progress in the field. So there is sharing, at least informally and through what is being published. As Stuart said, if there is something that is very, very proprietary and that you have some an advantage, you don't want to sort of publish that. But I think there is a lot of collaboration going on in the field, as everybody's interest is not to go back to the 1990s or the 80s where there was this winter of AI. I mean, I just met a startup yesterday and they did his PhD in machine learning in the 90s, and he had to go into hibernation for 10 years because nobody wanted to touch AI at that time. But at this point, we don't want to go back. It's sort of the spring of AI. It feels like it is spring of AI. We don't want to sort of go into another winter. So I think there is a shared thought process behind everybody to try to share as much as possible and advance the field. So I think we'll see a lot more of that. But as it comes to things that give you some advantage, you're going to keep it to yourself.
So did we have any questions from the audience?
Yeah, we have some questions from the back. For quite a while, there's been talk about using some sort of biometric identifier as a means of authentication. Why hasn't that taken off, and is it really the fix that people think it is?
I mean, I can give a little bit from some of my folks from my Qualcomm days are here. We had an investment early on in a company called Validity, which provided the fingerprint, one of the fingerprint readers for the PCs. And it just felt like the behavior change required to make that change, was not giving the consumer enough benefit just to log in. And I think now things are changing because of what the iPhone has done, and I think that has led to a lot more on the phone itself, at least, being an entry point of the phone. It's just not secure. I mean, I would say Stuart will probably tell you it's just not as secure. It's more of a convenience.
What's not as secure?
The biometric is not as secure as anybody would believe. So I think it's definitely convenient. It's become more convenient for users to use it. In the past, it's not taken off because the convenience was just not there. In a PC, I just log on. I don't, there's fingerprint readers on a PC for many, many years without any usage. I think the phone is finally seeing that, and I think that's going to go, but it's still, I think, more of a convenience factor. I'll let you.
Yeah, my big thing with any security is it has to be invisible, pretty much invisible to the user for it to be adopted. They almost have to adopt it without knowing they're adopting it. And my famous experience was I was started to build security practice and team at Kaiser Permanente, and I had made a small little policy.
It's a big hospital chain.
Yeah, a little hospital chain, but I made this policy change corporate-wide, and it had gone out, and the policy was very simple. You needed to have a passcode on your Wi-Fi router, SSID of some sort, and with a passcode. And I got a call from the head doctor telling me in no uncertain terms that the policy that I had just put forth was going to kill at least one patient a day. I was like, all right, we have a problem here of communicating. Let me talk to you about what this is trying to do. And I just listened to him a lot about what he said. Look, if it takes today it takes me 8 seconds to get into patient data. It takes me an extra second, it could be too late. I could misdiagnose, I could mistreat, etc. And this is what's going to kill patients. And so I said, okay, fine. All sales start with no, so fine. So what I started to get to know, what he really means is it just needs to be invisible. So I actually, on the call, I said, look, if I can make this policy change and not only keep the same login time to patient data, I can actually reduce your time to patient data. Would you accept the policy change? He says, yeah. So it's exactly what I did. I walked in, I looked at the overall configuration of all the routers, was able to figure out some major misconfigurations, changed that, put the policy in, they got more secure and got faster record times. Now, that told me a lot. Security really does have to be extremely invisible. So one of the reasons I think why, things like biometrics and other forms of two-factor authentication just don't get broad adoption is because it's too difficult to use. And when it's too difficult, people don't use it. Now, with the phone, I think the advent of the phone and some of the technology there, it's starting to get better where it is quite easy to swipe, but it is also easy to hack. So the easier it is to use, it's usually easier to hack. So a new paradigm has to really get applied here, and I think AI is perfect for that as well, to be able to apply it to identity.
Is there one last one, I think?
Yeah, just last question. Yesterday we talked a little bit about the Mirai attack and how that impacted consumer IoT. Are we taking enough precautions from a cybersecurity perspective when it comes to releasing new devices? Should there be some sort of standards that companies have to reach before they actually release products to consumers?
The FDA has put forward some
Yeah.
guidelines in this area, but they're only guidelines.
And there'll only ever be guidelines, and until maybe Trump takes office, and then maybe. He's been promising more prescriptive cybersecurity. So I do have hope on that front. I've been up on the Hill multiple times. I've testified in front of Congress multiple times about this very issue of IoT security. We released a big report a couple years ago on Operation Cleaver, which was Iranian hackers hacking up global critical infrastructure around the world, embedded systems included. And we exposed that fact. And the one question I kept getting asked is, what can we do as lawmakers to prevent this kind of stuff from happening? And the only suggestion I can really come up with is provide prescriptive mandates.
Prescriptive meaning,
Look, to prevent an attack, you need to do A, B, C, D, E, F, and G. And it really isn't rocket science. I mean, the steps that they need to take to get the 80-20 on the risk formula is very, very simple. I mean, if you just did one thing, all of the Yari attacks would never have worked. The one thing, don't embed a username and password with the product. That's it. Like, that whole worm would never have happened. So either from a generated password, one-time passwords, two factors, some other form, but just not an embedded one that you can look up in a manual or online in Google and get. So, and that's how that worm worked.
last word, more regulation, less regulation in cybersecurity?
I think time for lunch.
Yeah.
Sounds good. Appreciate it, guys, and thanks for listening.
All right. Thanks so much, everyone.